Well, hey there, scholars. This is Andrew Franklin, and this is a mini lecture dealing with virtual reality ethics. In this particular presentation, I'm going to spend some time defining virtual reality. After doing that, I'll talk about the accessibility of virtual reality products. Following this, I'll talk about research methodology for virtual reality. You're going to find that research methodology involves physiological measures in addition to online surveys. I'll spend some time talking about models of immersion in virtual reality. In particular, I'm going to hone in on two models that are typically used to look at virtual reality immersion from a neuropsychological perspective. And then finally, I'll wrap up the presentation by talking about ethics in virtual reality with a marked focus on beneficence and non-maleficence and the need to get proper informed consent. Virtual reality is an ecologically valid, interactive, and multimodal sensory stimulus presentation that allows naturalistic interactive behaviors to take place in a controlled setting. Virtual reality is very much still in its infancy, and there's a lot of research, basic research, clinical, personal, or otherwise, out there with most of the public research studies being comprised of case studies, open clinical trials, and uncontrolled designs. For many researchers, this technology and virtual experience enhances human ability to investigate neurocognitive functioning when persons are faced with everyday activities and situations. Reduced cost, smaller and easier to use equipment afford the lay public and the academic researcher a virtual experience at home or in the laboratory. Virtual reality experiences filtered through head-mounted displays can use smartphone technology as well as the hardware of computers to provide virtual experiences. Prices for the head-mounted devices can range from $100 to $400. The computers or smartphones that accompany them can range from $750 to $1,500. Popular brands through Google, Samsung, Nvidia, and Oculus Rift abound and can be bought right off of the shelf. Virtual reality-based experiences allow researchers to immerse participants in simulations that produce a sense or presence of being there. Presence has been described as the effect felt when controlling real-world objects remotely. How to go about assessing how immersed an individual feels from a cognitive and affective standpoint has involved subjective approaches that use self-report questionnaires. Others have gone the route of using psychophysiological metrics over self-reports to get at the effect felt by users when real-world objects are controlled remotely. Suh and Profit in 2018 developed the stimulus organism response framework to enhance understanding of the relations among technological stimuli, the organism's experience, be it cognitive or affective reaction to content, sensory stimuli, and perceptual stimuli, and the impact of using immersive technologies. Those that contend that presence is best described as a neuropsychological construct rely on interoceptive predictive coding model and the forward inverse model of presence. The interoceptive predictive coding model is a dual processing model that says presence results from executive functioning inhibition, that is, controlled cognitive processes are inhibited and predictions about emotional signals that are aroused by automatic responses to sensory stimuli. Of the areas of the brain involved, which include cortical, subcortical, and brainstem, it seems that cortical areas have the strongest influence. Seth and colleagues contend that individuals inhibit their controlled cognitions to prevent mismatches between what they predict they will experience versus what they actually experience. The forward inverse model of presence argues that the feeling, automatic processes, of presence provides feedback to the controlled processes about the status of activities. In a nutshell, the user perceives changes in feelings of presence and the user's activities are modified accordingly. Predicted states are compared with actual states in this model, and in that way, this model is very similar to the interoceptive predictive coding model. A few studies have confirmed that presence is a neuropsychological construct that establishes neural correlates of presence and immersion. Given that individuals may interact or share space in a virtual environment, Giuseppe Riva and colleagues have developed a model of social presence that includes three different layers. These three different layers are others' presence, interactive presence, and shared presence. And they use these layers to understand how users perceive the presence of another as social entities, living or synthetic, in a virtual environment. In order for virtual reality to be considered as technology of the extended mind, the user would need to continuously interact with the virtual reality, and the person immersed in the virtual environment would have to perceive the algorithm adapting the experience as being an actual extension of his or hers mind. In other words, after the user interfaces with the virtual reality for a period of time and transitions from controlled cognitive processes to automatic processes due to familiarity, in turn, the virtual reality will adjust the type and amount of content given to the user, assuming it's a learning algorithm. All of the aforementioned factors may lead to virtual reality being a part of a person's extended mind if the person relies on the tech for new or old information as new sites and virtual environments are being explored. Virtual reality ethics literature includes several general approaches to ethical guidelines and ethical codes of conduct. There have been focused discussions on clinical virtual reality games, virtual human avatars, and cyber learning. I will address some of the risks and recommendations for virtual reality in controlled settings now. Cyber sickness, also known as simulator sickness, is a subtype of motion sickness that can occur when a person is immersed in virtual reality. This unpleasant side effect can be described as a group of symptoms such as motion sickness, fatigue, headache, eye strain, and or nausea. Sensory mismatch, when stimuli from the outside environment is being perceived differently by different senses, and postural instability, that is, if a person is unable to maintain the posture necessary given the stimuli from the outside environment. These things are thought to be potential causes. Some researchers, such as Ardema and colleagues in 2010, argued that the effects of virtual reality are similar to symptoms found in dissociative disorders, that is, depersonalization and derealization. The researchers argue that the effects of virtual reality may impact the agency and responsibility needed for moral life, given how adaptive virtual environments can personalize experiences and enhance presence, making it increasingly difficult for some to stay in the real world. Some researchers have pointed to how games played in the virtual reality environment, such as cyberball, can lead to feelings of ostracism and rejection. These virtual reality games involve other virtual players, ostensibly controlled by others or a computer, in which users are included or excluded in an activity. The ostracism and rejection that users feel when they are not included in an activity appear to be neurologically and psychologically on par with ostracism and rejection experienced offline. If beneficence and non maleficence are to be upheld in the virtual reality context, then a minimization of cyber sickness needs to occur. When used therapeutically to help patients overcome pain, phobias, and anxiety, a patient's autonomy and beneficence must be upheld in virtual reality interventions. While virtual reality platforms provide an opportunity for the emotional processing of anxiety provoking stimuli, which is very compatible with the emotional processing model, it must be noted that there may be situations in which patients do not wish to experience the benefits of psychological manipulation. If a therapist were to insist that the intervention was used, then this could be a violation of the person's autonomy. Sometimes participants may develop therapeutic misconceptions about what virtual reality interventions can offer. Some may want to try it simply because it is novel, and in a therapeutic context, they may believe that virtual reality therapy is better. Depending on the goals and the mental health challenges of the person, it may be the case that talk therapy is better, as supported by research literature. The cyberpsychologist will need to be cognizant of established techniques, their efficacy according to research, and how to counter therapeutic misconceptions in their patients. Virtual reality based neuropsychological assessment holds a lot of promise given the heightened computational abilities to present stimuli, automatically log responses, and analyze data. This is a significant upgrade from relying on static stimuli with little to no adaptive interaction, since the professional can present dynamic stimuli that simulates real life situations. The primary ethical concern for these virtual environments surrounds the use of head mounted displays. Given that some participants, especially older adults, may have sensitivities to adverse effects such as cyber sickness, this type of approach may be contraindicated. It may be better to present simulations via a desktop. Cyberpsychologists must obtain informed consent from participants and clients using language the participant/client can understand, and consenting is to be performed as soon as possible. Informed consent typically involves the purpose of the research and expected duration and procedures, the participant's rights to participate and withdraw from the research/procedure once it commences, the foreseeable consequences of declining or withdrawing, factors that may influence their willingness to participate, such as potential risk, discomfort, and adverse side effects, prospective research benefits, limits of confidentiality, incentives for participation, and who they can contact for questions about the research and research participants' rights. Obtaining informed consent in virtual reality research allows for increased treatment effectiveness, improved cooperation, enhanced trust, and opportunities for participants to guide the next steps in treatment. There are unique considerations regarding informed consent that should be thought through when working with children and older adults. Persons who are legally incapable of giving informed consent should still be asked to give their assent according to APA ethical guidelines. It may be difficult for persons from vulnerable populations to completely grasp what exposure therapy entails. It is very important that the cyberpsychologist offers straightforward and accurate information on the side effects of virtual reality exposure therapy, what the type or study or treatment will entail, the potential benefits of virtual reality exposure therapy, and alternative treatment approaches.